Good afternoon, students. Today we want to have a review of paper 6. Paper 6, as you are aware, chemistry has paper 6, which is alternative to practical. Today, I just want to look at the last question, which came in May, June 2023. It came in May, June 2023. Usually, the last question has to do with planning. And you're going to find out that when it comes to A level, you'll be asked also to do a question on planning. It's actually a standalone paper. But at O level or at IGCSE, there is usually the last question whereby examiners are testing your capability to plan and experiment in a chronological way. So in May, June 2023, as you can see on the screen, there was a very interesting question which came where you were given a metal polish, which is a mixture of 4 substances, and the properties of these substances were given. The properties which were given, they had to do with their solubility in 2 solvents, which happen to be water and nitric acid. So you have a metal polish in which you're supposed to actually determine the percentage of silicon 4 oxide, which is a component of the metal polish. So given these solvents, a student is supposed to decide as to how do they find out the percentage of silicon oxide in the mixture. Once again, this is a metal polish. It contains propanol, ethanoic acid, iron 3 oxide, and silicon 4 oxide. So in water, propanol is soluble, ethanoic acid is insoluble. In water, iron 3 oxide is also insoluble in water. But then what you need to do is you want to try and find a method which will isolate, maybe a physical method which will isolate silicon 4 oxide. The very, very first topic that you do in chemistry has to do with methods of separation. So this is the methods that we're going to play around with until we can isolate silicon 4 oxide. So we cannot use water because if you want to isolate silicon 4 oxide and collect it as a residue, we cannot do that because iron 3 oxide is also going to remain as a residue. But if we could use dilute nitric acid, okay, you're going to find out that dilute nitric acid is going to dissolve propanol, is going to dissolve ethanoic acid, is going to dissolve iron 3 oxide, okay? You have to warm it a bit so that the reaction goes to completion, but it's not going to dissolve silicon 4 oxide. So that's it. That's the basis of the method that we are going to use. Okay, so you are provided with a symbol of the metal polish and dilute nitric acid and common laboratory apparatus. Okay, now this is an experiment, okay, and you are planning an experiment. It's like you're going to write a recipe to someone whom, if they are going to have a stage by stage follow-up of your method, they'll be in a position to repeat this experiment and get exactly the same results. So when you are doing this, when you're answering this question, I would encourage students maybe to have a stage by stage detailed explanation, but don't have a generalized explanation as it were, okay? Because we want to find percentage of silicon 4 oxide. We are not just supposed to take silicon 4 oxide. We are supposed to be very, very particular. For instance, I would say if you are going to do this one, you have to start by telling us that you are supposed to take a known mass, okay? So we are going to actually say, all right, fine, let's take a known mass. So my very first stage, which will be my stage number 1, okay? I'm going to say weigh, okay? I'm going to say weigh. Let's just say weigh, weigh 0 point. You see, the examiner also want to know whether you are aware of your practical masses that can be used in the lab. You can say weigh 2 kgs, okay? I'm just going to say weigh 0.2, okay, grams, 0.2 grams of metal polish, okay? So that's the first stage that you're going to do here. Weigh 0.2 grams of the metal polish, okay? And I think let me write just here. I'll remove this one and let me extend this so that I write in the same line. Okay, I'll extend it right up to the end there. Okay, and okay, place in a beaker. okay? So already you are telling the examiner what you are going to do because they've told you that you are provided with dilute nitric acid and common laboratory apparatus, and a beaker is one of the common laboratory apparatus that you could have, okay? And then after that, okay, your stage number 2, what you're going to do next year, you are going to, stage number 2, you are going to add, okay, add 25, okay, 25 cubic centimeters of dilute, okay? You're going to add 25 cubic centimeters of dilute, okay? Dilute nitric acid, okay? Into the beaker, okay? Again, I have to extend a bit and push it there into the beaker. All right. So stage number 1, I've taken 0.2 grams of metal polish and placed it in a beaker. And then into the same beaker, I'm going to add 25 cubic centimeters of dilute nitric acid. Okay. And then what I do next, okay? Now, I have taken my metal polish. My metal polish contains propanol. It contains propanol, ethanoic acid, iron 3 oxide, silicon 4 oxide. The moment I allow dilute nitric acid to interact with the metal polish, something is going to happen. Propanol is going to dissolve. Ethanoic acid is going to dissolve. Iron 3 oxide will also dissolve, but I have to do something to quicken up the dissolving process of the iron 3 oxide. So what do I do? Okay, so I move on to stage number 3. Okay, I need to do something to allow my iron 3 oxide to also dissolve. Warm, okay? I'll say here, gently, all right? Gently warm the mixture to, okay, to dissolve. Gently warm the mixture to dissolve. Just informing the examiner that I am aware of what I'm doing to dissolve, okay, iron, to dissolve iron, my iron 3 oxide, okay? Extend this a bit so that my oxide will fit. I want to dissolve my iron 3 oxide. Okay, let's make it small caps. My iron 3 oxide, okay? Right, so what I've achieved so far is I have actually done the solvation of propanol, ethanoic acid, iron 3 oxide by using nitric acid. Okay, so what I now have is a solution of nitric acid, which has dissolved ethanol, ethanoic acid, iron 3 oxide. But check in the table, silicon 4 oxide has not dissolved. So if I were to look at the container, I'll be seeing some residue of silicon 4 oxide at the bottom, but at the top, I have a solution. Propanol has dissolved, ethanoic acid has dissolved, iron 3 oxide has dissolved. Okay, once again, going back to the topic on separation of mixtures, how do you separate an insoluble substance from a soluble substance? I suppose you can all remember that the method which comes to your mind will be filtration, okay? Because I simply want to now isolate the silicon 4 oxide from the solution which is consisting of propanol, ethanoic acid, and iron 3 oxide. So I perform filtration, okay? Right, so at this stage, I'm afraid I'm going to just remove what I've written there, okay, so that I can write stage number 4. Let me just take my page down. Let me take my page down so that I can write a bit more, okay. Let me take my page down, all right. All right, I take my page down. I've written stage number 1, stage number 2, stage number 3, stage number 4. Okay, remember when you're writing, you'll be continuing. So I move on to stage number 4. Okay, right. So I am now on stage number 4. What do we do now? Okay, using filtration apparatus. Using filtration apparatus. Okay, filter. I want to filter off, okay? Using filtration apparatus, I want to filter off, I want to filter off silicon, okay? Silicon 4 oxide is not dissolved. I want to filter off silicon 4 oxide. I want to filter off silicon 4 oxide. I'm going to filter off silicon 4 oxide. Okay, right. Okay, make this caps, small caps again. Silicon 4 oxide. Right. Then I'm done with that stage. And then I move on to my number 5. Okay. My number 5. Now, I suppose with your teachers, you were shown how filtration is done. When you're filtering using the filter funnel, you are supposed to wash off the residue because you see you have wet silicon 4 oxide. It's still having the solution or the dissolved substance. So I want to ensure that all of them will go down into the filtrate. All right. So you can also write here that wash. Okay. You wash the residue. Wash the residue. Wash the residue. Wash the residue to ensure that all dissolved substances or dissolved substances drain into the filtrate. Okay, right. So I now have my residue. I'm sure now that what has remained mostly is going to be silicon 4 oxide. Okay, what I'm simply talking about here, I'll just draw a diagram on the side, which is not necessary, but just for illustration purposes. Okay, right. And then I go on to number 6. Number 6, I prefer that you answer your question in this way so that you will be in a position to score the maximum marks here. All right, so I filtered off. I discard the filtrate. Now I remain with the residue. So what do? I am going to dry the residue. Dry the residue. Okay, dry the residue and weigh it. Dry the residue and weigh it. Okay. Now, there are various methods that we can use to dry the residue. Okay. This is silicon oxide. It's actually a strong macro molecule, and therefore it can withstand heat, but you're not always encouraged to heat substances strongly in an oven whilst you're drying them because some substances can decompose, but you're just supposed to dry it carefully. Okay, you can put it in a desiccator, and then that action will actually allow all the other substances that were there to evaporate. Okay, so you weigh it. Now, after that, I am going to have my dry silicon 4 oxide. Okay, I'm going to have my dry silicon 4 oxide. Okay, right. So you dry it, and then using the mass of the dry silicon. And let's extend a bit here so that we are in a line. Using the mass of the dry silicon for oxide, calculate, okay? Calculate the percentage, calculate the percentage composition, okay? Calculate the percentage composition as follows. Now you are informing the examiner that you are treating your results, okay? How are you going to treat your results? That's what we are going to do now, which will be our final stage, okay? How are we going to say? We are going to say as follows, okay? As follows. Then here we say percentage of silicon, percentage of silicon for oxide will be equal to mass of silicon oxide, mass of silicon oxide, everything over mass of nail polish. Okay, let's just extend the so that we can write it like that. Okay, mass is equal to, okay, let's just do it this way. All right, then here we can say times 100 times 100%. Okay, so if you use this formula, you are going to actually calculate the percentage of silicon for oxide. Okay, right. So if you check, the maximum number of marks allowed in this paper was about 6. Okay, and I have about 8 points which are listed there. 6 is the maximum number of marks that is required. Again, what is the key to obtaining maximum marks here? Make sure that your steps are in chronological order. Okay, study what you've been given there. Usually these questions are asking a certain experimental procedure, and in most cases some of these questions come from methods of separation, a certain procedure, experimental procedure that we do in chemistry. But it is important that you list your stages in chronological order, so that if someone is reading, it's like you're instructing someone maybe how to prepare cookies or how to prepare scones in the kitchen. Or when that recipe is given, someone should be in a position to follow it without difficulty and be able to obtain the correct results or the accurate results. Okay, so this is one way of looking at that paper, paper 6, and this question in particular, which comes in the final phase of the paper, in the last page. And this question usually is the one which will separate those who get A star or A in this component. So I hope I've actually helped you to understand how you can have a good or a better approach to understand these questions. Thank you very much.